Well, good morning. We're up to part like 7,000, I think, of the 3585A dumpster score. And in the last video, we did the power rails and got them DC-wise in the right ballpark. I took a look after the video finished. I took a look at them, and they did have quite a bit of ripple and stuff on them. So I've ordered a set of capacitors to go in and replace everything to hopefully decrease that ripple. But for the purposes of running the machine, it seems to work for the moment, and we're not at the point of looking at the accuracy of the scan or anything. We're just really trying to see if we can get it to the point where we can see something on the screen. So with that said, what I wanted to try and do was to see, well, can we read something now that we've got the unit powering on, the fractional N VCO is going around and starting and scanning, and we're seeing the sum and FRN lights flicker showing that. So we should be able to see something. So what I've got, and actually let me just minimize this. What I have here is I have my I have the unit plugged into my GPIB network. I have a National Instruments GPIB ENET 1000, which enables me to connect to it via Ethernet and then spread out. And then I have a bunch of HP 32704, I think it is, GPIB extenders, so that I carry GPIB throughout my lab and house. I guess that's very rarely said, GPIB through my house. Anyway, so what I've got, I have this set up, the unit is turned on, it is plugged in, and with KE5FX's tool, we can go in and acquire a plot from the unit at GPIB address 11, which is what the default address is and what the unit is in fact set to. So let's go do that. And there we go. We've got the unit set up. We're pulling a thing. So that's good. So what that sort of means, if we come back to here, is that the display driver circuitry is basically working because we can do that. Now let's see if we can get it to actually read something. So to do that, what I have is I have my 3325B set to run. So you can see here that what I'm going to do is I'm going to set the frequency at 100K, 100 kilohertz. I'm going to set the amplitude at 4 dB. So let's write that. And I can see that my unit has clicked over. So if we refresh that thing, you should see there is just up here, you can see that spike. So let's come in here and let's write some control to the unit and say, okay, we've got center frequency of 100 kilohertz and I want to do a 10 kilohertz band. So let's write that. And I can hear a bunch of relays move on the thing. So let's update this again. And there we go. We can see that we have 100 kilohertz. We have the marker set at the center frequency. It's reading about 3.1 dBm. Let's neither here nor there. Let's just go with it for the moment. But what that's telling me is that pretty much we can, in fact, read something from the unit. So now what I want to do is I want to see where we lose, if we lose signal to the CRT. So if we have a look here, now this is the analog display driver, and if we move down here in this part of the system, so let's just zoom in and bring that over. What we can see here is basically everything goes through the analog system and then it ends up at these outputs. Now the top two here go to the high voltage display driver board, the high voltage power supply board, I think, or they go to the amplifiers. We'll have a look at it in a minute. But those same signals, as you can see, pop out through these buffers to the X and Y display on the back of the unit. So we should be able to see those signals through that X and Y. And so what I've got is I have set up an old Tektronix 2235A scope in XY mode. So let me move the camera so we can take a look at that. So here we have, I turned the unit off so we can see that the XY mode is showing the thing. And if I turn the unit back on, we can basically see the, which way does this go? No. You can pretty much see the XY display. Now, there is a Z blinking thing there, which I don't have hooked up because I don't think the 3585A outputs it in the same voltage setup as the the scope expects. So this is just XY, no blanking. But you can see the scan, you can see some of the text. It's a little fuzzy. You can see that it's digitally generating the gradical lines. So overall, what that tells me, at least that's what it implies to me, is that the digital part of the display is correct and most of the analog display board is correct. So now I think what we need to do is go take a look at the actual high voltage supply and see if we're getting anything on the, see if we're getting anything there, because if the high voltage supply isn't working, then it won't drive the CRT. So let's move the camera back and we'll take a look at that. So now we're set up. This is the somewhat concerning part of the unit. This is the high voltage board. And you can see here that the cathode voltage is set to minus 2.4 kilovolts. And this is the high voltage multiplier, and coming out of this part here is 9.4 kilovolts. So it's mildly concerning poking around on that to see what's happening. Now, that said, the jumper 8 over here carries the signals coming in from the XYZ board, and so it also carries in the voltages that are coming out of those low voltage supplies. So the first thing we should do is just take a look at those voltages, and the first one I'm going to measure is 105. Now, if we look here at my board, you can see the voltages are here, and 105 is coming in on pin 4 of this connector, which is that one in the bottom there. So what I'm going to go do is put my little clipboard down, and I'm going to get in on that pin before I turn the unit on, so that I don't have any chance, or at least I minimize the chance of maybe I'm going to like fry something. And so if we turn the unit on, we can see, yep, 105 volts. So that's good. So that's telling us that we're getting 105. So then the next pin is going to be, let's take a look at, hang on, let me take a quick look here. Let's take a look at pin 6, which should be, hang on, 4, 5, 6. And that's going to be minus 15. And that's good enough. Let's take a look at 7, which is going to be plus 15. Yep. And let's take a look at 8, which is going to be plus 18. And they're all close enough. Again, remember, we're just trying to get something on the screen. So we're getting our low voltage supplies, as they refer to it, through that that system. So what we want to do now is I want to just check to see if we're actually getting high voltage stuff. So let's turn this off and let me swap the probe over. So for the digital engineer, this is the somewhat concerning part, the mildly disconcerting part of the whole process. So this probe is a 1,000-to-1 probe, and it should allow me to probe the heater and the cathode voltage off this board. Now, there are actually 2 test points just in here for those 2 items. Now, the heater, the problem with this is that while this is a very good, or at least is a good high voltage probe, their accuracy is plus or minus 1%. And so at 1,000 volts, plus or minus 1% is 10 volts. The reading of the heater circuit for the CRT is, 4.5 volts RMS on top of whatever the floating voltage is. So I'm guessing I could measure the thing, but it won't really, the voltage, but it won't really tell me much. It'll just tell me whether there is a voltage present on there, not that we're actually heating anything. So with that said, let's get in there. Let's take a look at that first point. Now let me just grab my sheet here again and make sure that I'm measuring the right test point. Okay, so TP66 is the right one, and we make sure that we're hitting TP66. Okay, so what I'm going to do is I'm going to put that on that cathode point there. And I'm sorry about the camera angle. It's so big, this is the best I can sort of do. But if we turn it on now, all right, we can see minus 2459, which is a little bit more minus than what the tag here is saying. But it is at least showing that we're getting voltage there. So now, if we turn that off, the next test point is test point 99, I think it is, which is the heater. Now, that test point, let me just check the schematic again. My alarm system has gone off. Hang on. Bear with me. All right, the squirrel has been successfully run off. So what you could read across here is basically the voltage across the heater circuit. You can see the heater comes into the CRT over here. I know virtually nothing about cathode ray tubes. They were old technology when I went to university, and you'll need to speak to somebody much more switched on than I am. But I imagine they gave us 2 test points because you can float a meter with those 2 test points and then read the difference between them as long as the meter isn't grounded. So I don't want to do that because I don't want to destroy a meter if I get it wrong. So I'm just going to leave that. But what we can do is if I just test against it, if I just probe that, at least we'll see if we're getting voltage on that. So let's go do that. Let's put it on just one of those test points. There we go. And let's turn the unit on again. And there we go. We can see that it's, 2461 there. And it's showing that at least we're getting something at the correct level. Let's see if without doing something. So we're 2461 there, 62, plus or minus 1%. Anyway, I think we're probably okay with like getting heater voltage out of there. All right, so with that, there's really not a lot more, I guess I can test, except if we come back to the schematic here. Just a quick update. I did in fact test. If you look over the right side of the high voltage multiplier, you can see that red cable that's in the spiral shield. That's the anode cable that goes to the front of the CRT, and it should be 9.4 kilovolts. And I did in fact disconnect the white plug there that you can maybe just see at the right of the screen, and it does in fact read 9.4 kilovolts. So that indicates that the cathode voltage at minus 2.4 is being generated correctly, and then the high voltage multiplier part is actually generating the correct 9.4 kilovolts. So return you back to the video. Let me see, is this where it is? Let's go back up. Yeah, if we come back to the schematic here, on that jumper 8, which is that jumper where we check the power supply, I should be able to see the grid drive and the focus drive, and I should at least be able to see what the signals look like. So with that, and my alarm system has gone off again, hang on. Oh, well, the alarm system has identified something else trying to break into the house. It could have been a squirrel, it could have been a raccoon, it could have been a plastic bag. Anyway, we are protected. So where was I before my alarm system went off? I think we were talking, oh yes. So the grid drive and the focus signal should at least look like that. So let's take a look at the grid drive. So I'm just going to just take that off. Let's get our probe in. And what we'll do is we'll hook that onto pin 5 there. And then we'll turn this on. Okay. So now what it says is 2 milliseconds per division, 1 volt per division. And so the grid drive, according to that, should be 2 volts. Okay. So that does not look correct. So we want that as 2 milliseconds. Okay. Let's bring, and we want that. See, that is way off because it's supposed to be 2 volt sort of peak to peak. And I'm reading more like 33 volts peak to peak. That cannot be right. So apparently, I was speaking to my father about this, who is much more experienced in the whole realm of CRTs and televisions. That he used to work for as a serviceman for radios and national instruments, national television, a national consumer electronics brand out of Japan and everything. So if the grid is being overpowered, then that will shut down the CRT. So if this is supposed to be, and as you can see, Sorry, I just kicked the thing. As you can see here, you know, we're seeing 33.8 volt peak to peak, and it's supposed to be 2 volt according to the thing. So that is being way overdriven. Now, the basic layout of the signal more or less sort of looks a bit like what we're supposed to be seeing there. Inverted, maybe. Yeah, it's, I think we're seeing the right thing. I just think it might be overdriven. Anyway, that leads us to our next area of investigation, which is what is going on with this grid signal and making sure we're actually getting the right stuff in. So with that, we'll call it quits for this video. And then I'm going to go off and do a bit of research onto that voltage stuff, and then we'll come back in the next video and see where we are. Anyway, I hope you found this interesting, and I'll talk to you again later. All right, thanks.